All right, guys, welcome back again. Is Idris Abdel Kader. So today we're going to talk about lesson 4, factoring part 1. Factoring a trinomial of the form ax squared plus bx plus c when the a, b, c are constant values. So today we're going to study the case 1 when a equals to 1. That means when the leading coefficient is equals to 1. In that moment, how we can factor it. So example 1, factor x squared minus x minus 42. So you can see here the leading coefficient is 2, and then the leading coefficient is 1, the degree is 2. So once the leading coefficient is 1, so how we can factor it? So I have x squared minus x minus 42. So the idea is to take the ending coefficient, which is the constant c, which is minus 42. Then you ask yourself, can I find two numbers? If I multiply them, it's give me negative 42. At the same time, if I add or I subtract those two numbers, I will end up by negative 1, which is the middle value all the time. The product must give you the constant value c, and when you add on, you subtract them, it must give you definitely the value in the middle right there. So you have to find the multiple of 42. So when you multiply negative 1 by 42, that equals to minus 42. When you multiply minus 2 by 21, so 21 is a little bit mess. When you multiply negative 2 by 21, you end up by negative 42. When you multiply negative 6 by 7, you end up by minus 42. You can see that can be not true, because when you multiply them is okay, but when you add, you end up by 41, which is different than minus 1. As well, the second example also, when you add negative 2 to 21, you end up by 19, which is different than minus 1. So the only case that can verify is the last one. When you add negative 6 to positive 7, you end up by negative 1. So actually, I have to change the sign right here and give the minus sign to the 7 to make that happen to become minus 1. So since you know that, you can find out. So you just put two parentheses, because the x is in a square, you share the x in between. So you can put the two value any parentheses you want. If I want, I can put the 6, x plus 6 times x minus 7, or I can say x minus 7 times x plus 6. It doesn't matter when you put the value. So that means here is the commutativity rule that you can apply. So another example, example 2, if I have x squared minus 6x minus 16, how can I factor that? Well, you take the constant value again, which is negative 16. You ask yourself, can I find two numbers? If I multiply them, it's give me negative 16. At the same time, if I add those two numbers, give me positive or negative 6, which is the middle value right there. So the first multiple of 16 is minus 1 times 16, which is minus 16, or minus 2 times 8 is minus 16, and minus 4 times 4 is minus 16. All right, so it's gonna be minus 16 right here. Okay, now the only case that can verify is the middle one, when you add positive 8 to negative 16, and here also I have to switch the sign and give minus to 8 that to make that happen. So when you're adding them, so you can see the answer is negative 6. So what happened, you share the value in between, because the x is squared, you can put parentheses x1 x here, and then the 2 and then the minus 8, you can put them wherever you want. If I want, I can put x plus 2 ahead of x minus 8, or I can put x minus 8 ahead of x plus 2. But it's still the same thing, so that's how we factor it. So the third exams, we have x squared plus 40x plus 400. So how can I factor that? Well, you ask yourself again, can I find two numbers? If I multiply them, it end up by 400. If I add or subtract them, it end up by 40. So you're looking for the multiple of 100. 1 times 400 is 400. 4 times 100 is 400. 20 times 20 is 400. 100. So the only case that can verify that is 20 times 20, and 20 plus 20 is 40. So you can see when you do the product, it's give you the constant value C, and when you're adding them, it's give you the value of B. So then you can share it in between parentheses. So you put parentheses, two parentheses, because the x is square, you share the x like this x, you share it like this. Now you take those two value, you put them wherever you want. If you want, you put the head of, you can switch them. It is okay with that. All right. So now let's see the case 2. The case 2 is when the a is different than 1. For example, example 1, I have 5x squared plus 7x minus 6. If the coefficient, the leading coefficient is past 1, so the technique is to take the leading coefficient, you multiply it by the constant value c, so that give you minus 30. Now you ask yourself the same question. Can I find two numbers? If I multiply them, it's give me negative 30. At the same time, if I add or subtract them, it's giving you the value in the middle. So you're trying to find out the multiple of 30. Minus 1 times 30 is minus 30. Minus 2 times 15 is minus 30. Minus 3 times 10 is minus 30. So the only case that can verify that is this one. When you multiply 10 by negative 3, you end up by minus 30. If you add negative 3 to 10, you get 7. So that's the two numbers that we're looking for. Now, this 7x, you have to rewrite it again. 7x can be 10x minus 3x. So you're going to substitute that in here. So instead of writing 7x, I'm going to write 10x minus 3 inside right here to make it 4 terms. So then you can see between 5x squared plus 10x, you can take 5x as a factor. So you end up by x plus 3, x plus 2. Now between negative 3x and 6, you can take negative 3 as a factor. You end up by x plus 2. So you can see x plus 2, that's a new factor. You pull out that. Then you open up the parenthesis. What is outside come inside. So you're going to put 5x minus 3. And that's it. That's how we factor it. Another example, I have 2x squared plus 5x minus 12. Again, the leading coefficient is past 1, so I cannot use the previous form. So what I'm going to do, I'm going to take the leading coefficient, I will multiply by the constant value, which is negative 20. 12 times 2 is going to be negative 24. Then I will ask myself, can I find two numbers? If I multiply them, I will end up by negative 24. At the same time, if I add or subtract them, I will end up by the middle value, which is 5. So the multiple of negative 24 is negative 3 times 8, negative 24, negative 6 times 4, negative 24, negative 2 times 12 is negative 24. So the only case that verify saying that you multiply them, you end up by minus 24, and then when you add them, you end up by 5 is 8 and negative 3. So this 5, 8, I can rewrite it in two terms, like 8x minus 3. So I will substitute that inside here to make it 4 term. You see, instead of 5x, I wrote 8x minus 3x, which is going to be equal to that. So in this two term, I can see that 2x can be a factor. So you're going to end up by 4 plus x, because when you multiply 2x by x, you end up by 2x squared. 2x multiplied by 4, you got 8x. So here I can pull out like negative 3 as a factor. So I end up by x plus 4, and then x plus 4, that's a new factor. You pull out that. So what is outside come inside. You put 2x inside here, negative 3. All right, so simple like that. So here's another example. Example 3, you have 3x minus x minus 2. So since the leading coefficient is past 1, I have to multiply the leading coefficient by the constant value, which is negative 6. So then I will ask myself a question, can I find two numbers? If I multiply them, it's giving me negative 6. At the same time, the two numbers, if I adding them, I will end up by negative 1. All right, which is the middle value right here. So you can see the case that verify that is negative 2 and 3. So negative x can be rewritten like 3x plus 2x. So I will substitute that by minus x, so to make it 4 terms. So I can see here 3x can be a factor, so you're going to have x minus 1. So here 2 can be a factor, you're going to have x minus 1. So x minus 1, that's the new factor. So whatever is outside will come inside. So that's how we factor it so far. So I hope this video will be helpful for you. So please subscribe my video and make some comment. Thank you and see you next time.